Hello and good day. Welcome back to our class. This is teacher Onin Guzman and our topic for today is properties of trapezoid and kite for grade 9 quarter 3. Let's talk about first some definition of terms. So we have a trapezoid is a quadrilateral with exactly one pair of parallel sides. Also, the bases of trapezoids are two parallel sides and the legs of the trapezoids are two non-parallel sides. The isosceles trapezoid is a trapezoid with congruent legs. And finally, we are talking about kite. It is a quadrilateral with exactly two pairs of congruent consecutive sides. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So parallel sides are called bases. So a trapezoid has two pairs of base angles and the non-parallel sides are called legs. So let's have this illustration. So VW is parallel to UX and UB and WX are non-parallel sides. So we have here angle A and angle B are called upper base angles. Angle C and angle D are what we call the lower base angles. Okay. AC and BD are called diagonals. And AD and BC are called legs. And AB and CD are called bases. So take note that an isosceles trapezoid is a trapezoid whose non-parallel sides are of the same length. So let's consider this illustration. So we have AB is the same as CD. Okay. Talking about the properties of a trapezoid, so we have the trapezoid consecutive angles theorem. Stress that the consecutive angles between the bases of a trapezoid are supplementary. So let's look at this one, guys. We have, okay, angle T and angle P are supplementary. So we can say that measure of angle T plus measure of angle R is equal to 180, as well as, okay, angle P plus angle A is equal to 180 degrees. Let's move on to another property of, okay, trapezoid. So we have isosceles trapezoid theorem. So the base angles of an isosceles trapezoid are congruent. Again, so let's consider this example. So we have angle B is congruent to angle S. So we can say also that angle A is congruent to angle M as well as angle B is congruent to angle S. So next we have isosceles trapezoid theorem. If a trapezoid is isosceles, then each pair of base angles is congruent. So let's have here this illustration. So we can say that CARE is an isosceles trapezoid such that angle E and angle R are congruent and angle C is congruent to angle A. Let's move on to the next property. So that is isosceles trapezoid diagonals theorem. Stress that the diagonals of an isosceles trapezoid are congruent. So let's look on this illustration. So we can say that CARE is an isosceles trapezoid if and only if the line segment CR is congruent to line segment AE. Moving on to the next property, so that is isosceles trapezoid opposite angles. Supplementary theorem stress that if a quadrilateral is an isosceles trapezoid, then the opposite angles are supplementary. So let's look on this illustration. So we can say that the measure of angle B plus the measure of angle M is equal to 180 degrees, as well as the measure of angle A plus the measure of angle S is equal to 180 degrees. Let's have some proving exercise. So we have here if a quadrilateral is an isosceles trapezoid, then the opposite angles are supplementary. So let's consider the illustration on the right side. Okay, so we have here AM is parallel to BS and AB is congruent to MS. So prove that BAMS with AB and MS. So we would like to prove that, okay, BM is congruent to AS. So let's have our proof. So for our statement number 1, we have trapezoid BAMS with AB and MS. Okay, so the reason is given. So take note that AB is congruent to MS because we have non-parallel sides of isosceles trapezoids are congruent. Number 3, so we have here angle ABS is congruent to angle MSP because we have base angle of an isosceles trapezoid are congruent. Moving on to statement number 4, we have BS is congruent to BS. The reason is we have reflexive property of equality. For number 5, we have triangle ABS is congruent to triangle MSB. The reason is we have the side angle side theorem. And finally, we have BM is congruent to AS because corresponding parts of congruent triangles are congruent. So let's move on to another definition of terms. So that is the area of trapezoid. So a trapezoid with bases RA is equal to B sub 1 and TP is equal to B sub 2 and the height is equal to H. So on our illustration, so B sub 1 and B sub 2 are parallel lines. So the area of trapezoid is given by the area is equal to the sum of the bases, so meaning to say base sub 1 plus base sub 2 divided by 2 times the height. So let's consider the following examples. So find the length of the median of trapezoid. By the way, if we say the median of a trapezoid is parallel to each base and its length is half the sum of the lengths of the bases. So let's consider, okay, the trapezoid DCBA. Okay, so EF is equal to 1 half times DC plus AB. So we will substitute the given. So we have this is 1 half of 15 plus 17. So EF is equal to 1 half of 32 or EF is equal to 16 units. Moving on to our example number 2. So find the length of the median of the trapezoid. So let's consider illustration on the left side. So again, so the EF is equal to BC plus AD times 1 half. But EF is actually 36 is equal to 1 half times BC plus 50. Now, so to solve for BC, I'll multiply both sides of the equation by 2. So I have 36 times 2 is equal to BC plus 50 only. So to eliminate the denominator 2. So solving further, I have here 72 is equal to BC plus 50. So solving for BC, so I have here BC is equal to 72 minus 50. So BC is equal to 22 feet. For our example number 3, we will incorporate algebra. So that's why find the length of the median and the bases of trapezoid ABCD. So take note that, okay, so FB is equal to 1 half times the sum of AB plus DC. So we simply plug in the value of FB is equal to 3x minus 4 is equal to 1 half times, okay, AB is equal to x plus 7, while DC is equal to 2x plus 2. So simplifying it further, so I have here multiply both sides of the equation by 2, so I have 2 times 3x minus 4. However, if I'll simplify this, so x plus 2x is equal to 3x, then we have 7 plus 12 is equal to 19. Then, distribute 2 to 3x minus 4, so I have 6x minus 8 is equal to 3x plus 19. Again, group together all the variables and numerical coefficient on one side. So I have here 6x minus 3x is equal to 19 plus 8. So I have now 3x is equal to 27. So if I'll divide both sides of the equation, okay, by 3, so I'll come up with x is equal to 9. Now that I found out that the value of x is equal to 9, so AB is equal to x plus 7. So therefore, that is simply as 9 plus 7. So here, AB is equal to 16. On the other hand, DC is equal to 2x plus 12. However, x is equal to 9, so that is 2 times 9 plus 12 is equal to 30. Finally, the median, FB is equal to 3x minus 4. Substitute the value of x, which is equal to 9. So that is why we have FB is equal to 23. Let's try another exercise. So find the length of the bases of the trapezoid EFGH. So let's look on the illustration on the left side. Okay. So take note that DJ is equal to 1/2 of FEF plus HG. So substitute the given. So we have DJ is equal to 8.5 is equal to 1/2. Okay, times 3y minus 2 plus 2y plus 4. So again, if we will simplify this by multiplying both sides of the equation by 2. So I have here 2 times 8.5. 3y plus 2y is equal to 5y. Negative 2 plus 4 is equal to positive 2. Simplifying it further, so 2 times 8.5 will give us 17 is equal to 5y plus 2. So, then subtract both sides of the equation by 2. So, I have here 17 minus 2 is equal to 5y. So, I have 5y is equal to, okay, 15. Then divide both sides of the equation by 5. So, I'll come up with y is equal to 3. Now that I found out that the value of y which is equal to 3, then EF is equal to 3y minus 2. Substitute the value of y which is equal to 3. So we have 3 times 3 is 9 minus 2 is equal to 7. Next, so HG is equal to 2y plus 4. So we have 2 times 3 plus 4. So we have 2 times 3 is equal to 6 plus 4. So therefore, the final answer is equal to 10. So let's move on to number 5. So quadrilateral IJKL is an isosceles trapezoid with bases IJ and LK. So MC is the median. So the measure of angle ILK is equal to 3x plus 10, while the measure of angle IJK is equal to 2x minus 5. So what are the measure of the other angles? So in order to solve this one, guys, so let's start with, okay, so the measure of angle ILK plus the measure of angle, okay, measure angle IJK is equal to 180 degrees. Take note that the opposite angles are supplementary in, okay, trapezoid. Okay, so specifically isosceles trapezoid. So with this, we can say we have 3x plus 10 plus 2x minus 5 is equal to 180. So simplifying it further, I can add 3x plus 2x. Then we have 10 minus 5. So I have 5x plus 5 equals 180. Then subtract both sides of the equation by 5. So I have 5x is equal to 175. Divide both sides by 5. So I come up with x is equal to 35. Now that x is equal to 35, then we can say that the measure of angle ILK is equal to 3x plus 10. So substitute the value of x, which is 35. So 3 times 35 is 105 plus 10 is equal to 115. On the other hand, measure of angle IJK is equal to 2x minus 5. Substitute again. So we have 2 times 35 minus 5 is equal to 65. On the other hand, the measure of angle LIJ is equal to the measure of angle IJK, which is also 65. Also, the measure of angle JKL is equal to the measure of angle ILK. So this is also 115. Now that we are done on trapezoids, so let's move on to kites. So a kite is a quadrilateral with exactly two pairs of congruent consecutive sides. So in our illustration, we have here AB is congruent to AD. So BC is congruent to, okay, DC. All right. So let's have a theorem. So in a kite, the perpendicular bisector of at least one diagonal is the other diagonal. So let's consider the illustration on the right side. So we have kite LOPE with diagonals OE and LB. So LB is a perpendicular bisector of OE. So that is the thing that we want to prove. For our proof, our statement number 1 is kite LOBE with diagonals OE and LB. The reason given. Number 2, start with number 2, with LB is congruent to LE and OB is congruent to EB because we have the definition of kite. For number 3, we can say that LO is equal to LE as well as OB is equal to EB because we have the definition of congruent segments. Finally, we can say that LB is a perpendicular bisector of OE because if a line contains points, each of which is equidistant from the endpoint of a segment, then the line is perpendicular bisector of the segment. So let's move on to the next theorem. So diagonals of a kite are perpendicular. So let's have actually kite ABCD. So AB is congruent to AD and CB is congruent to CD. So we would like to prove that AC is perpendicular to BD. Okay, for our proof, statement number 1. So AB is congruent to AD, CB is congruent to CD. So the reason is the given. For number 2, we can say that AC is congruent to AC. Okay? Because of the reflexive property of equality. For statement number 3, we can have triangle ABC is congruent to triangle ADC because of the SSS theorem or side-side theorem. Okay, next. We have here angle BCA is congruent to angle DCA because we have corresponding parts of congruent triangles are congruent. And for number 5, we can have the triangle DBC is an isosceles triangle. Our reason is the definition of isosceles triangle. Now, to continue for our proof, statement number 6, so AC is an angle bisector. We can have the definition of angle bisector as our reason. For number 7, CE is an altitude to the base BD because we have the vertex angle bisector postulate. For number 8, CE is parallel to BD. We can say the definition of altitude. And number 9, CE is on. Okay, take note that CE is on AC. We have the definition of collinearity. And finally, we can say that AC is perpendicular to BD because of transitivity. So let's move on to kite diagonal bisector postulate. Stress that the diagonal connecting the vertex angles of a kite is the perpendicular bisector of the other diagonal. So we have here RP bisects the line segment QS. Okay. Next, we have the kite angle postulate. Stress that if a quadrilateral is kite, it has one pair of opposite angles congruent. So let's look on this example. So angle Q is congruent to angle S. Next one. So kite angle bisector postulate stress that if a quadrilateral is a kite, it has one diagonal that bisects a pair of opposite angles. So let's look on this example. So we have RP bisects the angles R and P respectively. On the other hand, if we would like to look for the area of a kite, so given a kite with diagonals AC is equal to d sub 1 and BD is equal to d sub 2. So the area of kite is given that the product of d sub 1 times d sub 2 divided by 2. So this is equal to the area of a kite. So let's consider the kite HUGS. So the name the pair of congruent and adjacent sides. So we have here, okay, line segment HU and HS. And we can have also line segment UG and line segment SG. Next, so if HU is equal to 15, what is HS? Since that HU is equal to HS, so we can say that HS is also 15. Next one. So if UG is equal to 3.5, what is SG? Take note that UG is equal to SG. So we can say that SG is equal to 3.5 as well. For number 9, so HG is equal to 24 and US is equal to 11. So what is the area of the kite HUGS? Take note that the area is equal to d sub 1, or okay, diagonal 1 times diagonal 2 divided by 2. Take note that our diagonal 1 is okay considered as HG and diagonal 2 is US. So if we will substitute that, we have 24 times 11 divided by 2. So we come up with 132 square units. And finally, if the measure of angle SGA is equal to 48, what is the measure of angle GSA? So since the acute angles of right triangles are complementary, so take note that we can highlight that part here. So we have angle SGA, okay, this is the part, and we have GSA. So actually, so these are the angles of, okay, acute angles of the right triangle. So we can say that measure of angle SGA plus the measure of angle GSA is equal to 90. So therefore, 48 plus measure of angle GSA is equal to 90. Since I'm looking for the measure of angle GSA, so that is 90 minus 48. So the measure of angle GSA is equal to 40. Okay, so that ends our topic on trapezoid and kite. Again, this is teacher Onin de Guzman. Do not forget to subscribe to my channel so that you will be notified about my new videos. Thank you.